I think right now my goal is to make a AND gate out of a not AND gate, which means I need to make a, well, this is a not AND gate, right? Because I press both, it turns off. And this is what, an AND gate? Yeah, this is an AND gate. If I copy this guy here, and then I just add a small piece for an inverter, I think that's all I need. So I think I'm gonna try that. I'm gonna plug out this guy, so that guy's power should go out. Let me try zoom in and let me get started here. So let's just plug it all out. It's kind of sad to undo. So we know that we need to basically have our output, which is this LED, to go to ground, right? So we'd have our power go to resistor, goes to the LED, goes to ground. So this should work right now. I can test it just to make sure that, yeah, so that works, it's on. Okay, so I'm plugging it out again. So now what we want to do is give this row, the circuit, oh, let me move him so you can see the resistor a little better. There he is. We want to give this another path to ground that is cheaper than the resistance in this LED, so that when we activate this path, this goes out. And for that, we'll use our transistors again. So holding it facing me, EBC, so collector is going to go in here. And then the other collector for a B is going to go into the emitter of A, right? So we have our power goes into the LED. Well, sorry, it doesn't go into the LED. It could go into the LED, but if we activate both of these, it can go into A's collector. And if the button's pressed, it goes out the emitter into B's collector. Up A's collector. Out the emitter into B's collector. Out the emitter to ground. So if we add a ground connection, like our green guy again. All right, I think it's in. It's not very pretty at all, especially when you see it from the side. It looks nasty. Look at him. He's like a crumpled worm. Now we just need our buttons, and then really that should be it. I'm gonna align these resistors just a bit. If we want to line up, let's say this is lined up with B's, the output is lined up with B's base, or you could say B's switch, then we need the power to go here to be transferred here when it's pressed and then go. So we're going to just attach this guy right here. And then A's switch needs to line up on this line. It doesn't need to, but it'll just make it easier and a little bit more aesthetically pleasing. So the resistor is already lined up properly, so now we just need to connect the actual output of the buttons across the chasm here. Chasm? But this guy, no, he's too long. Damn it. Man, I really need to get just a wee bit smaller connection, but I don't think I have. Where's this guy? He's like a maroon. I really haven't noticed him before. He's probably really good. Oh yeah, look at that. Maroon, where have you been all my life? Damn, that's perfect. That's the most efficient connection. Maroon man, where are you? Tell me where your friends are. Oh, it's in the red pack. So there's all these red ones in there too. And that's why he's hard to see. He's buried by the red. Oh, these guys are great. Yes, you are my friend. All right, perfect. Bloop. Okay, so this should work, I think. Oh, so wait, does it even work here? That would be amazing. Let's see. These guys I need to get more of. Oh yeah, I feel like this guy knows what's going on. He barely doesn't work here, but I think he'll stretch and be fine. Maroon Man, don't disappoint me. Let's see, I'll bend him slightly. And maybe, I feel like the connections on the power rail just, oh yeah, he goes in. But they're very firm on the power rail. The other one's not so much. That's perfect. Look at that. So we have, let's just do a quick review, make sure all of our power coming on is resisted. So we have no raw power going in to destroy stuff. So power goes from resistor into our LED and to ground. That's one path. But if the transistors are connected with our buttons pressed, let's pretend they're both pressed, click, click, then power comes in, goes up resistor A into the base, but he's clicked, so it goes out the emitter into transistor B's collector, and it's also pressed, so he's able to jump over to the emitter and emit out to ground, thereby skipping the LED. So let's plug this in and see. I think this looks good. Getting faster at this too, which is nice. Oh, look at that, they turn on with such unison. So these should be identical. Both buttons should turn him off. Yeah, perfect. And now we need to flip this, right? A little flippity doodle, flippity doodah, little flippery action. I'm gonna move the camera unit because it's a little far from me when I want to show this. All right. So how do we flip it? Well, that's a good question. How does one do that? We have our inverter slash not OR gate. So if we had the inverter slash not OR gate with only one input, making it an inverter, then we should be able to feed that transistor, the base in there, our output from the not AND gate and get an AND. So I'm going to plug out my power again. And let's try and do that. So I guess we need more power coming in, which means another resistor. So I have a guy. I'm going to bend him up and cut him off. Sounds terrible. All right. I turn him into a Spider-Man kind of person. Spider resistor. One nice smooth cut. Whee. Let's put him in. So he'll just be like on 15. Let's say 15 is where the inverter begins. So that's in, nice and neat. And let's think about this. We have our out. This is our output. This line is going to be our output from our not AND gate. Let's go into the inverter. So an inverter, remember, needs to be a signal that's on by default. Let's get another LED. Get another LED. And let's do what we did here, which is let's just send this guy. So this should be on by default, right? This will be powered up. Again, we can test this. We can plug it in. Do one quick check. Power is resisted going to the LED, so I should be fine. Boom. So now we have 3 lights. We're making Christmas decorations. We need some green ones. I should make it green. It is December right now. Green, where's green? Green. All right, green man, where are you? Oh, I have a green guy sitting right here. Let's see if this works. Because I think the last time the green didn't work, right? I don't remember. So if we put this guy, the long end in, and we ground him, then, oh, look at that. It really is like Christmas. On the camera, it looks a little bit saturated, if that's the right word, and in person, it's a very nice green. It's like a party. So we have our Christmas decorations, almost. That'd be cool to make it blink. That'd be like a cool little project. So we know that now our inverter is on by default, which is the way it should be, right? There's no input right now, so that means by default, if there's no input, then it's 0 input, it's off, so this should be on. So that makes sense. So now let's get another transistor. We have our little transistor man, flat side facing me, EBC, left to right. So we are gonna put this guy in, and he is gonna go into the same point in parallel, right, as the green guy. So he's gonna be the cheap way home. Cheap way home. But the bridge can only be taken home when the base is activated, right? So that's parallel on the same row as the LED. So the electricity has a choice to make. Can he go through this guy and go back, go home? Yes, but it's a terrible journey through mountains and a blizzard. And this is sunshine, nice paved roads, I-95. But the I-95 is only open sometimes when the switch is activated. So the input now for the base, and this is the part that gets cool now because we're really putting two gates together for the first time. Oh no, what just happened to him? Oh, he flew up this way. So now we're connecting transistor to transistor in a way that I haven't done yet, and now I need a gray cable. So we're outputting from the not AND gate into the base. I think this works. Now we need to ground this guy. All right, that seems to work well enough. All right, I like how this looks. It's a little confusing. So we know that our not AND gate is working properly. By default, it will go through the LED and illuminate. When we press both switches, toy boat. That's another one. Toy boat. If you try and say toy boat like 10 times fast, it gets funny. So we have power going up. This guy's on by default. We click both of these on, and then the power is able to transmit into our base, which should allow this. So both these are on by default. When we click both of these, this hits energized, which makes this guy energized, which makes the electricity coming off of the power skip him, turning him off. But I don't think I did it right. Damn, did I not do it right? Because this should be off by default. This guy should be off by default. Damn it. Right? He's an AND gate. Hopefully nothing explodes. Yeah, I don't know what I just did. I did nothing. I made a switchable dude. Yeah, there's something wrong here. I don't think I did this right. All right. What did I do wrong? Yeah. Just from the walkthrough, it didn't seem right. These need to be opposites. These need to be opposites. So this guy should feed into this base. Yeah, I have it backwards, I think. I have it backwards. Wait, we need you, Mr. Redman. Where are you? Come back. I did not mean what I said. All right, I got him or his brother. Somebody that looks like him. So yeah, so this guy needs to be grounded. This dude right here needs to be grounded still. You are grounded. I have to do my little bending trick. So this wasn't him. This is definitely your brother. Because he still would have been bent. All right. That goes in. So where we went wrong, or where I went wrong, let me now pull you into it. This guy needs to be grounded, but this dude. So I'm gonna move him upwards so that we can. This guy should feed into the other transistor. Down. Man, what's the best way to do this? Because when he's on, he will activate this guy, turning this guy off. Yeah, so it's the opposite. So our LED is our output. I guess I should skip this LED. I don't really need it. We know it works. So I'm gonna skip this LED. I'm just gonna put a cable because it's a little tricky. Perfect. So that's a path to ground. All right, so let's see. So let's plug it in. Hopefully nothing blows up. Yeah, it works. It's an AND gate. Or it's an inverted not AND gate. So this guy's receiving power, but the NAND gate is on by default, right? Which means this transistor is on by default, which means that the electricity coming out of this resistor, this is our output, right? He can go home cheaply since this guy's always activated. This transistor C is always activated, skipping the LED. But when we activate both switches, it turns off this signal, which turns off this transistor, which forces the electricity to have to go through the green LED. And it works. And we can use, again, I feel like we can use this output because it's the last sequence. So as long as this transistor, sorry, this LED or the output, you know, we can move it. Like, you know, we can put this anywhere we want into a circuit, and as long as it goes home, it's useful. So I'm pretty happy with this, that it worked out. I also didn't really think about the fact that we'd have to connect more transistors together in a more complicated way, which is cool to start doing this, because I really want to get into the point where they're all like connected together and doing I don't know what, but interesting things. So this is good. Let me plug it in one more time because I just plugged it out and make sure it works. All right, lights on. And he's on, yeah. So here is our collection. We have an OR gate, boop. And we have a not OR gate, boop. Also an inverter, if we remove one of the buttons, but you've probably seen that enough, so you're good. This is an AND gate, an AND gate here, yes. Whee! One doesn't work, the other one doesn't work, but together it works. And a not AND gate. Both of them turn off. So here's our core logic. Sounds cool when I say that. Core logic unit. No, this is all very basic stuff that this one schematic really taught me a lot. So thank you, whoever made this. I should credit it, I guess. I gotta go find it and credit it. And now I'm gonna try and make the exclusive OR gate, which should take the output of this NAND gate and this OR gate. So if they have a baby, but we put them through yet another AND gate. So if we use these outputs for these inputs, so output and output, then this should become an exclusive OR, right? Except we'll have 4 buttons. So we need to rebuild this, but with 2 buttons, and these 2 feeding this, I think. So that will be cool.